Very good morning, all of you. We are going to discuss a new chapter, that is a new concept, that is the protein synthesis. As you know, protein synthesis is the third step of the central dogma. All of you know what is the central dogma, that is the DNA get replicated in itself, that is the DNA into the DNA, and this DNA is get converted into the RNA by the process of transcription. The RNA is get converted into the translation into the protein by the process of translation. ओके. सो ट्रान्स्क्रिप्शनमध्ये तुम्हाला काय होतं ते एक एक्झॅक्ट त्याची आयडिया आहे की ट्रान्स्क्रिप्शनमध्ये जी इन्फॉर्मेशन आहे डी एन एवरची ती इन्फॉर्मेशन कॉपी केली जाते आणि तिचं कन्व्हर्शन आर एन एमध्ये केलं जातं आणि हा आर एन ए फर्दर प्रोटीन सिंथेसिससाठी वापरला जातो. ओके. तो वापरला जातो म्हणजे काय की त्याच्यावरचे जे असणारे कोडॉन सिक्वेन्स टी आर ने रीड करतो आणि त्यापासून पुढे प्रोटीन तयार करतो. हेच आपल्याला आज बघायचं, दॅट इज द प्रोसेस ऑफ ट्रान्सलेशन. ओके. ॲज यू नो, ट्रान्सक्रिप्शन इज हॅपन इन द 3 stages, that is initiation, elongation and termination. In bacteria there is only one restriction, RNA polymerase is there, but in case of prokaryotic there is a 3 type of polymer that is responsible for the synthesis of particular RNA from the DNA. So properties of the genetic code. What mean by the genetic code is almost one of the most important things. Genetic code is an triplet form of code in the form of ATGC, UGC, ATGC, AUGC, which is responsible for the particular code for the particular protein. Some of properties of this genetic code. The code is universal, means all prokaryotic and eukaryotic organism use the same codon to specify which amino acid. Means both in case prokaryotic and eukaryotic case, in both case these codes are same. Then another property is the code is triplet. 3 nucleotides make one codon. Okay. Means there is a 61 codons is there, which is the code for the amino acid, and 3 that is the UAA, UAG and UGA are the nonsense codon which are responsible for the termination of the translation process or protein synthesis process. So how these 64 codons are generated, as we can see in next few sites. Okay, slides. The code is degenerate. Okay, for the particular amino acid more than one word can be used. Okay, so then the code is non-overlapping. The base in mRNA is not used for 2 different codons. Okay, so it is non-overlapping. Okay, the code is commaless. There is no single special single or commas between the codons. The code is non-ambiguous. A particular codon will always for the same amino acid wherever it is found. Okay, this is somewhat some properties of genetic code, and this is the diagram of genetic code. You can see UGAC and UCAG and UCAG, just like a checker code. There is a so just like multiplication, this U and U, this you can see this U, that is the U, and also this U. Okay, U, then U, and this one, this C is there. Okay, then U, this A is there. Okay, and G is there. Okay, this is the codon, and this particularly this amino acid. This codon is responsible for the phenylalanine amino acid. This codon is for the leucine amino acid. Okay, then tRNA, the basic important thing in the translation process, that is the tRNA is responsible for the transferring of the amino acid from cytosol to the globin chain of polypeptide chain. Okay, so ribosome is there. There is a genetic code. Main components of the translation is the genetic code. Second one is the tRNA and the ribosomes is there. Okay, all of you know what mean by the ribosome. Ribosome is responsible for the protein synthesis, or it called as a machinery for the protein synthesis. Okay, as all of you know what does it means. Okay, so bacterial ribosome consists of two subunits of equal size, that is a larger having a sedimentation coefficient of 50s and smaller of the 30s. Okay, this is the that particular structure of ribosomes in the case of prokaryotics. Okay, so actual process of the translation we are going to see now. So first of all, remember that the components for the particular translation is genetic code is there, that is triplet form of code. Up to that, what mRNA is there, tRNA is there. Okay, and ribosome is there, and somewhat some elongation factors which are present, which play an important role in the process of translation. Okay, so translation is the first stage of protein synthesis, biosynthesis, a part of the overall process of gene expression. Okay, means in this step the actual information which is the code by the mRNA is get transferred to the protein by the help of different tRNA and with the help of ribosomes. Okay, translation is a production of protein by decoding mRNA producing in a transcription. It occurs in cytoplasm where ribosomes are located. Means location of the translation, that is in cytoplasm where the our ribosomes are located. Ribosomes are made up of small and large subunits which surrounds the mRNA. Okay, this is the then translation. In translation, messenger RNA is decoded to produce a specific polypeptide according to the rules specified by the genetic code. If the RNA have a particular triplet codon, then there is a own that particular specific amino acids are comes in the growing chain of polypeptide. Okay, so totally the sequence of polypeptide chain is totally depends on the sequence or nucleotide sequence which are present on the particular your mRNA. Okay, the use of mRNA sequence has template to the guide the synthesis of chain of amino acids that form protein. Many types of transcribed RNA such as transfer RNA, ribosomal RNA, small nuclear RNA are not necessarily translated into an amino acid sequence. Okay, this is all about the introductory part of translation. The translation process involves four various steps, that is the activation, initiation, elongation and termination. So as you know, particularly in activation step, there is the activation of tRNA. Okay, means the particular amino acid which is specific for that particular tRNA that get binds with the particular that tRNA, and in the presence of enzyme amylo acid tRNA synthesized. Okay, so this is the particular tRNA is responsible for or specific for the particular amino acid. Okay, when the particular amino acid is joined to the carboxyl group to the 3' OH of the tRNA by an ester bond. Okay, then when the tRNA has an amino acid linked to it, it is called a charge. Means when the tRNA is get binds with a particular amino acid with the amino acid binding site of the tRNA, then the particular tRNA is called a charged tRNA. Okay, this is the structure of charged tRNA, that is the fermion, methionine tRNA, that is the mite. Okay, so it is a formyl group. Okay, and the particular tRNA, particular your methionine residue is get bound. Okay, this is the structure of particular your charged tRNA. In prokaryotic, initiation requires large and small ribosome subunits. Okay, mRNA, the initiator tRNA, and three initiation factor, that is the IF1, IF2, F3, and DTP. For the initiation purpose, these various components which are required. First of all, ribosomes is there, mRNA is there, initiator tRNA. That means the FMET tRNA. Okay, that because your initiation codon, that is AUG. Okay, so the tRNA is called the initiator tRNA, which contain that particular methionine amino acid. Then the initiation factors, that is initiation factor 1, initiation factor 2, initiation factor 3, and GTP. The overall sequence of the event is as follows. First of all, IF3 is their factor, is binds to 30S subunits, that is the ribosome subunits, which helps to prevent the large subunit binding to without an mRNA molecule and forming the inactive ribosomes. Consider this point. The IF3, that is initiation factor 3, is bind to particular small subunit of the ribosome. Okay, and when it binds with a small subunit of ribosome, it prevents from to binding of the large subunit of ribosome to the particular small subunit. This is because 30 subunits or small subunit must be bind with your mRNA. Okay, then and then it will bind with your large subunit. Okay, so this is the main function of IF3, that is initiation factor 3. And then initiation factor 2 complex with the GTP and IF1. Okay, this coupled your action of these two factors then binds to the particular small subunit and will assist the large charge initiator tRNA to bind. Means in this case, the particular these two factors are help to initiate a tRNA to bind with particular your ribosome site. Okay. Then this 30S subunits attached to the particular mRNA molecule, making use of ribosome binding site on the mRNA. Okay, here actual mRNA, where the particular protein synthesis gets started at that point. At that point is called, or that site is called as the ribosome binding site, where the particular mRNAs get bind with particular your ribosomes. The initiator tRNA can then bind to the complex by base pairing of its anticodon with the AUG codon on the mRNA. Okay, so AUG is the initiation codon which is present on the mRNA. Its complementary sequence is present on the initiator tRNA. And at this point, IF3 is get released, and its role is keeping the cell apart from the helping and the mRNA to the bind are complete. Okay, so after that process, IF3 is get removed, so the large subunit, that is get bind with that particular what we can say to the small subunit. Okay. So it is called as a pre-initiation complex or initiation complex. Okay, in this figure you can see the 70th initiation complex. Okay, you can see here 30S ribosome is there, and this is the mRNA. This in the process of in the presence of IF3, this particular mRNAs get attached to the ribosome. Okay, after that there is a IF3. Okay, and this is the what we can say in this case, FMET is get attached with that particular its initiation for that is the AUG. Okay, and particular 30S ribosome is there, which get binding with the particular 30S in the presence of initiation factors 1 and initiation factor 2. Okay, this is the formation of 30S initiation complex. Okay, so after that there is a 3 sites which are present in the ribosome, that is the A site, P site, and E site. Okay, the A site is called as a acyl tRNA acyl site or arrival site. Okay, P site means there is a peptide bond formation site. Okay, and E side means exit site. Okay, these are 3 sites which are present in the particular your protein synthesis. Okay, so elongation also divided in 3 steps. Amylo acid tRNA delivery. In this elongation phase, there is some elongation factors are also there. elongation factor Tu is required to deliver the amino acid tRNA to A site, and energy is consumed in the step by the hydrolysis of GTP. Okay, so EFTU is responsible for the delivery of amino acid tRNA to the A sites. Okay, then the released elongation factor Tu, GDP complex is regenerated with the help of EFTS. Okay, these are the various factors which are responsible for the elongation process. Okay, so these are the some important concepts in this. So elongation takes place in this way. Here your P side is there. Okay, here is the A side is there. Okay, in the P side initiator of tRNA is get binded already, and this A side upcoming continuous upcoming tRNA or amino acids get attached and add in this process. Okay, then the second, there is the peptide bond formation. It happen in the P sides of the particular ribosome, and the peptide transferase enzyme is responsible for the peptide bond formation. Okay, this is the diagram for the peptide bond formation. Okay, then translocation. Translocation happens by the process, by the presence of enzyme, that is the translocase, and GTP binds the ribosome in the energy consuming step that happens. That is a translocation, means it continuous translocate the particular peptides, and there is a formation of peptide bonds, and there is a continuous long chain of amino acids. Okay, so after the translocation termination happens, and termination happens when this stop codon is there, that's the UUA, UAG and UGA, which is a, what we can say, which is a seen in the particular your mRNA sequence. When this happens, no tRNA can recognize it, but releasing factor is recognize this process. So these three factors is responsible for the termination process in the particular your termination process. It also involves some release factors which are responsible for the recognition of the termination codon, just like RF1 is recognized UAG and UAA, and RF2 recognize UGA and UAA. Either RF1 or RF2 binds to a termination codon. It induces peptidal transferase to transfer guanine peptide chain to a water molecule rather than another amino acid. Okay, this is the particular your factors. These factors are responsible for the particular termination process. Okay, so this is all about your translation process. Okay, so any doubts you can ask me through WhatsApp. Okay, thank you.